Welcome to part one of the weathering notes. Again, as always, if you get done watching these videos and you have any questions about weathering, please come talk to me when you get back to class. And if you're not from my school, if you're not in my class and you're watching this, please keep in mind this is intended for an 8th grade classroom, so it's not intended to be an all when it comes to weathering and erosion. So if you're a high school teacher, if you're a college teacher, or if you're taking this class in college, it's just a basic introduction to weathering. So when we talk about weathering, the first thing you always want to ask is, well, what is weathering? Well, weathering is simply the breaking down of rocks. It's the breaking down of these rocks into smaller segments or sediments. If you remember from our rocks unit, we talked about sedimentary rocks, and sedimentary rocks come from sediments. Well, where do we get those sediments? They come from broken down rocks. So weathering is the breaking down of rocks. Now when we talk about weathering, weathering involves both the process of chemical and mechanical weathering. And both these processes occur in place. There's very little movement involved with weathering. Later on we'll talk about erosion, which is where most of the movement takes place. Now mechanical weathering, sometimes mechanical weathering is called physical weathering. That's why I have physical in parentheses there. And it involves physically breaking rocks into fragments without changing the chemical makeup of the minerals or the rocks themselves. And we'll talk about chemical weathering in a bit. Now it's important to keep in mind that weathering is a surface or near surface process. Typically, weathering does not happen deep within inside the earth. Now we're going to talk about some different methods of mechanical or physical weathering, and we're not going to talk about all of them. We're not going to talk much about abrasion today, or salt wedging, or impact weathering. We're going to keep it more simple, and we're going to talk about ones that more commonly happen here in the Midwest. Now, one thing I like to talk about is thermal expansion. This is the repeated daily heating and cooling of rocks that cause expansion. Cooling causes contraction. The different minerals that make up rocks, as they're heating and cooling, and the sun might be heating one side of the rock in the morning and a different side in the afternoon, and this change in volume puts a lot of stress on the mineral boundaries. And this is a good picture of what may happen. The rocks tend to crack. They almost look as if they're peeling off. So when we look at here, it's hard to see from this perspective, but it almost looks like you can take a piece of the rock and just peel it off, almost like peeling paint. And sometimes they actually call this spalling. Now another type of physical or mechanical weathering is called frost wedging. Sometimes this is called ice wedging. Ice wedging. And this is when water will get into the cracks, and maybe during the day it's above freezing and you have some rain and the water gets in the cracks, but at night it freezes. And this constant freezing, thawing tends to break down rocks. And one of the reasons why is that when water freezes, it actually expands by 8%. Some of you may have witnessed this if you've ever left a can of soda in the fridge too long, or not in the fridge, but in the freezer too long, and you come back several hours later and the can has exploded. Well, that's because the aluminum couldn't hold back the soda, and the soda, which is mostly water, as it expands, there was no room in the can for it, so it was under such extreme pressure that it just burst the can open. So here we see some pictures out at Devil's Lake, Wisconsin. And you see these cracks in here as water can get in there, especially in the fall and in the spring when the morning temperatures are probably still freezing, but during the day it gets above 32 degrees, and then at night it freezes again. Water can get into these cracks, and over many years the cracks can get larger and larger and larger. And as it looks like this rock right here, it almost looks like it could fall. So you can see these cracks. It almost looks like it could just slide off and come tumbling down and create some more talus. So here's some more pictures out at Devil's Lake, and again you can see all these cracks here, and these have some interesting vertical cracks too. You can actually get down in there and you can squeeze in between there, and as water gets in there it will expand and the cracks will get larger, and eventually pieces break off and you get a lot of talus like we see out here at Devil's Lake. And talus are just broken off pieces of rock that tumble down, and they form a large layer of broken down rocks, typically at the bottom of these cliffs. And here you see some ice wedging taking place more in the northern part of the North America. Not necessarily North America, could happen in the mountains, but maybe up in Canada or any place higher in altitude. What is exfoliation? Exfoliation, well, when the bedrock breaks along flat sheets, along joints which parallel the ground surface, this is caused by the expansion of rocks when the pressure of overlying rocks is removed by erosion. And this is sometimes called unloading. So if you can imagine, this rock right here, this is an exfoliation slab from Yosemite National Park, California. This rock may have formed miles below the surface of the earth. And because it formed miles below the surface of the earth, there would be a lot of rock layers on top of this rock layer. And all that pressure pushing down on a rock, well, that's a lot of pressure. Well, over time, this might have been due to uplifting, or the surface above this rock might have eroded away. And so over time, now it's exposed at the surface of the earth. Well, not that rocks have memories, but all that pressure that was built on them, the rocks still want to be pushing up against that pressure. And as a result, sometimes slabs come off. Or in this case, there's a, if you can see it right here, a lot of times geologists, I didn't take this picture, but a lot of times geologists will put objects in a picture so you can get size perspective. And this would have been from a camera lens. And this would have been the cover for it. But what happened with this one, this rock again would have been formed deep inside the earth, but because of all the pressure that was on it, and now it's all being released, it actually peels off almost like an onion. If you look here, you can see the different layers that have peeled off over times. And this would be called exfoliation, and sometimes it's called unloading. Now, plant action, sometimes this is called root wedging. This is simply when roots work their way into cracks. Now, as a homeowner, I have this issue with my driveway where grasses will get into the cracks of the driveway, and it seems like the cracks keep getting larger and larger and larger. So you can see how these roots are getting into the cracks. This is a picture out at Devil's Lake again, and this picture was taken on top of a large rock. So you started having smaller plants, and then you get larger plants, and eventually you're going to get some trees growing into these cracks, and the cracks are going to keep getting larger and larger and larger. So here's another picture out at Devil's Lake. This picture, I'm not sure where this picture was taken. I want to say out by Lafarge. It might have been in Devil's Lake as well. So here's one out by Lafarge, Wisconsin. Again, you see you got this side cliff here. It's not really necessarily a steep cliff, but all of a sudden out of the rocks you have this huge tree coming, and this tree, its roots have gotten deep inside these cracks, and it's actually breaking the rock apart. So this is a kind of an interesting picture. You can see the tree in the background back here, and you got this whole slab. But if you look here, these are all roots, and they've look like they've cracked the rock here, and it looks like they're going right underneath this entire rock, and it's broken it apart from the rest of the slab. Animal action. This is the digging, burrowing, and the pulling up of roots by animals. Could be this badger, could be a wolverine, could be a mole, could be lots of different animals. It could be you crawling out on lakes out at Devil's Lake, or crawling out on the rocks and helping break the rocks apart. So that is physical weathering. What's chemical weathering? Chemical weathering involves a chemical change in at least some of the minerals within a rocks. For example, rocks that contain iron rusting. That's chemical weathering that's taking place. Marble changing into gypsum when exposed to acid rain. That would be an example of chemical rain that's happening. Now water. Water sometimes is called the universal solvent. Water really tends to dissolve lots of different things. So you're going to see a lot of water in these next couple slides, or at least water being involved with the process that's taking place. Now normally water, when it falls from the sky, has a pH about 5.5, and if you know anything about the pH scale, 5.5 technically is considered an acid. Now, do most scientists consider it to be acid rain if it falls at a pH of 5.5? Nah, typically, you know, in Wisconsin, the DNR is going to say it's got to be somewhere around 5 or below 5. Other places, they'll say typically if it's about 4 or less, they consider it to be acid rain. But even a 5.5 is slightly acidic. And some people ask, well, why is natural rain slightly acidic? Shouldn't it be pure? Well, we've got all this carbon dioxide in the atmosphere, And even water, when it's in the atmosphere, it'll mix with this carbon dioxide and it'll actually create a weak carbonic acid. And that's where if you add water and you add carbon dioxide, you get carbonic acid. And we're actually going to make a weak carbonic acid in one of the labs that we do. Now, is this acid really strong? Is it going to burn you if it gets on your arm? No. But over time, it can, cause your skin to be irritated. And over time, it will tend to break down rocks. Now, other things that water can mix with, if there's sulfur dioxides in the atmosphere or sulfur oxides, it will create a weak sulfuric acid. And if there's nitrogen oxide, sometimes these are called NOxes, it may form a weak nitric acid in the atmosphere or nitric acid in the atmosphere. But one of the neat things that this acid can do, and the acid I'm referring to is the carbonic acid. Remember, when water mixes with carbon dioxide, it creates a weak carbonic acid. This weak carbonic acid actually dissolves away limestone, or at least the calcite that's in the limestone. And as a result, these cave formations form. So if you've ever been to places like Mammoth Cave, we even have smaller caves here in Wisconsin. They basically all were created in pretty much the same way. And one of the interesting things, if we back up a second, so here you see this guy in a cave. Sometimes the caves get so large, and if they're near the surface, the ground above it is too heavy and the cave itself will actually collapse. And a lot of times you're going to get these sinkholes. And here you see a home that has fallen into a sinkhole. So hopefully no one was in the home at the time that this happened. Here's an interesting thing. If you look down here, this person didn't necessarily drive this car in here. This car might have been parking, but it actually, if you see the bottom here, the whole bottom half of the car disappeared. This car actually fell down into a sinkhole. Here's a sinkhole in Guatemala. Now, the last couple slides, if we back up, these are pretty small sinkholes, but look how deep this one is. Now, not all sinkholes, remember, are man-made. A lot of times there may be sewer pipes or maybe water pipes, and these pipes break, and then they erode away the sand and the dirt and the soil, whatever you want to call it, underneath the pavement, underneath the cities, and eventually these places cave in. So this is in Guatemala, and this one right here is going to be very deep. If you were on top of that, you probably did not survive. This one right here, some of you might recognize from the news. This was actually in a nearby town called Milwaukee. It's Wisconsin's largest town or city. And this is actually a Cadillac Escalade. And this, the results of this was, this just happened a few years ago. And there's 5.5 inches of rain in Milwaukee that day. And this happened about 8 p.m. The bottom of it, so here's a Cadillac Escalade. So you can see those are pretty large vehicles. But when we look at the size of this, from one end to the other end, the people who went in there, the geologists, estimated to be about 40 feet wide. And when we look at the depth, it's kind of interesting that this landed on top of the Escalade. But when we look at the depth of it from here up to here, geologists are estimating to be about 20 feet deep. And the interesting thing with this Cadillac Escalade is that it was full of gas. So even the following day when they went to pull it out, the Cadillac Escalade, the car was actually still running. And this is actually a man-made sinkhole. Now, Milwaukee did have 5.5 inches of rain, but what had happened is one of the sewer lines or the storm drains had a crack in it, or it broke. So here you can see it right here, and you still see a bunch of water coming through it. Well, as that pipe broke or cracked, the water started to seep out, and it started to erode away all the material underneath. So eventually the city street, because there was nothing underneath it, the city street collapsed, and it just happened to collapse when this car was on it, which makes sense because it's a larger vehicle, so that extra weight collapsed the street and it dropped down into the sinkhole. Now, one of the interesting things I've heard about this, and I don't know if it's entirely true or not, was because of all the publicity from Cadillac for having this Cadillac Escalade, they're having it still work the next morning and having it still running after everything that's been happening, is I heard that the owner of this vehicle actually got a new vehicle. Whether it was a brand new Cadillac Escalade or whether it was a used one, I'm not sure. But that's just something I'd heard. Whether or not that's true, I'm not entirely sure. One of the other things that I want to talk about, this kind of is a blend between physical weathering and chemical weathering, and that is lichens and mosses. Now remember, mosses are a type of plant. Lichens, lichens are one of those interesting things. They actually have two parts. A lot of times lichens will consist of a fungus, which tends to be the dominant part of the lichens, and a lot of times they'll have a partner which actually makes the food through photosynthesis. For example, they might be made of fungus and an algae. Now some of these lichens secrete acids, and which these acids will dissolve the minerals in the rocks. Others are able to break tiny flakes from the surface by expanding when wet and contracting when dry. Still others form chemical compounds with rock minerals that are absorbed by the lichens. So these lichens and mosses a lot of times will be the first things that start the process of weathering. So the chemical and physical weathering caused by the lichens and other sources produce a habitat for mosses and eventually higher plants which continue the breakdown of the rock surfaces. So when we see some of these rocks, again, you're going to have your lichens and your mosses. A lot of times they're going to be the first plants there. Again, mosses are your plants, lichens aren't plants, but they're going to be the first things there to help to start this breaking down process of the rocks. So this was a picture taken of some moss out at Devil's Lake. And eventually you can see the mosses, and you can actually see some of both here. You've got some mosses on here. You've got some lichens here. It almost looks like an algae right there. And then eventually they're going to be making cracks, and they're going to be getting in the cracks and enlarging the cracks. And eventually these cracks got large enough so that these ferns are starting to grow on these rock layers. That does end part 1 of our notes, and as always, if you have any questions, any concerns about this weathering video or the weathering notes, if you want to just talk about them more, just please ask me in class. I'd be happy to sit down with you and talk with you and go over any of this with you again. As always, great job, and we'll see you in class. Bye.